All right, so today we're going to go ahead and finish up 6.4, the central limit theorem. So last time, or yesterday, what did we learn about the central limit theorem? We learned that if we were going to take from a population, we take a sample, we do a simple random sample, then what? We know that this guy and this guy are the same. Right. We also learned that this guy is equal to, well actually this guy, right? This guy is equal to this, but there were some conditions that had to be met. What were they? Bless you.
Thank you.
What conditions had to be met?
It had to be normal.
Okay, this has to be normal, because if this is normal, this becomes normal. If it's not normal, then what?
If you have more than 30 samples, it's
Okay, so if I have more than 30 samples, it doesn't matter. Because if you take enough, if you do enough, more than 30, this becomes normal anyway. Right? What if it's not greater than 30? Then what? What are you looking for? You have to do a dot plot, right? Remember? You have to do a dot plot. And you're looking for no skewedness, no outliers, right? Okay. Then this becomes normal also. Okay. So that in a nutshell is what we learned. Okay. All right. So we're on page 270. Introduction to hypothesis testing. Hypothesis testing. We will go into great details about hypothesis testing in chapter 8. We're going to plant a seed here today though by doing example number 3. Okay. Assume that the population of human body temperatures has a mean of 98.6 as is commonly believed. Also assume that the population standard deviation is 0.62. This is based on the data from the University of Maryland researchers. If a sample of size 106 is randomly selected, find the probability of getting a mean of 98.2 or lower. Okay? So we are taking this is my sample distribution, and if the population mean was 98.6, we can say that the sample mean is going to be 98.6 because, how can we make that assumption? Because it's an unbiased estimator, right? It's unbiased estimator, they're the same, just as we just pointed out earlier, right? So we're going to do this, 98.6 with a standard deviation of what? What's the standard deviation of the sample? The standard deviation that are given is what? 0.62, that's the sample, that's the standard deviation of the population, right? That's the sigma, right? So we have 0.62, but then we have to correct that by making this correction, right? Okay? All right. And if you do that, we get, the book says 0.0602. 0.0602. Okay, becomes the very small, started with this standard deviation, now it's almost tenfold or greater than tenfold less, right? Because this is 0.06, where this is 0.6. Okay. So I want to find 98.2. 98.2 when it's lower than 98.2. Okay? All right. So if I did a sample, what is the odds that it'll be lower than 98.2? All right. So how would I find that? Norm CDF. Eliana, what is my lower limit, or lower bound here? My lower bound is down here, right? My upper bound would be this. What's my lower bound? I am
Negative 100.
We'll just call it 0. To upper bound is 98.2. What's the next thing? Which is 98.6. Standard deviation, which is 0.0602. Spencer, what do I get? Or what did you get? Because I'm not doing it, you're doing it.
It means times 10 to the negative 11, so it's 0.00.
What'd you get? What'd you get? E what? What'd you get? 1 e to the negative, so e to the negative 11 is it? This is what you get? So what does this mean?
It's 0.00000000.
Just 10 zeros.
It's 0, right? Right? So you have 0% of this being down that way. That's what it's saying. It's really, 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 really unlikely for this to happen. Right? So in the hypothesis testing world, there are 2 ways that this can be lessened here, right? One is that because when we did this, we assumed that this was the average, or this was the mean, right? This was the mean, and we got really, really unlucky, and it was 98.2, right? That's one explanation to this. What is the other explanation? The other explanation is that this is not true, right? It actually isn't 98.6. It's something lower, right? So, we assumed that this is true, right? We assumed this is true. So, assuming that this is 98.6, we assume this, and we got a unlucky draw, or a bad draw, or an unlucky sample, right? This is option number 1. Option number 2 is mu is actually less than 98.6, right? And that's why it's down here. That's why it's so low. So which do you think is more plausible here? If I get this. What does this mean? It means there's a 0% chance this is going to happen, right? If this is your mean, right? Which means that which is more likely here, 1 or 2? 2 is more likely, correct? Right? What if I did the norm CDF and I got 0.10? What would you say then?
It's about accurate.
I don't want to give it
It's a little too, we're not sure. Okay, let me reword the question. Is it statistically significant if I got 10%?
Yeah.
Maybe. Remember we made an agreement on what statistically significant was. What was it? 5%. So it's greater than 5%,
Yes.
which means that I have to do this. At that point it is, well, I just got a bad draw, right? Because it's not significantly low enough to call it statistically significant. You understand that? You understand that? Okay, so this is what we will do, and so we will call this the HO, or the null hypothesis. We will call this the HA, the alternative hypothesis. Okay, and this is the one we are trying to disprove, or we think that this is not correct. But we're going to assume it's correct and say, oh, hey, look, I did this, and guess what? I got something that's really, really, really significant. Therefore, this is not true. Therefore, I reject this, and I have significant evidence that this is true. Do you see the logic there? Okay. Okay. If you don't get it right now, that's okay. We're going to go again. We'll touch it again, like I said, in detail in Chapter 8. But this is the logic behind hypothesis testing. Okay? Blah, 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 blah. And then there's a correction for a finite population. And we're going to skip that. I don't need that. Yeah. Okay. We're good. We're good for today. All right. So what did we learn? We learned hypothesis testing, kind of, the null hypothesis, the alternative hypothesis. We found that there were two different ways to explain something that was out of the ordinary. Right? Either we just got a bad draw, or the assumptions that we made were incorrect. Right? And we were going to find out or find a way to determine that. And that's what significance testing or hypothesis testing is all about. Okay?